So for this worksheet, it's the same formulas. Remember that these formulas right here should be written V1 over T1 equals V2 over T2. So this is a fraction, that line, that's numerator and denominator, okay? Also, we're adding the combo law. So the combo law is, as you notice, this Boyle's law, Charles' law, Guy-Lusset, and Avogadro, only two variables are changing. For example, for Charles' law, only volume and temperature are changing. You're holding the number of moles constant and also the temperature constant. For example, if you had a balloon, you have the same number of moles in there, 3, and you're just heating it up. This would be cold and this would be hot. So you're heating up the same number of moles. Okay, so I'm sorry, not temperature constant, you're holding pressure constant. Okay, so two variables are changing and two variables are constant, two variables are changing. This one, the combo law, you have 3 variables changing. As you notice, the numerator are P and V, P1, V1, and the denominator is T1 equals P2, V2, and the denominator is T2. Okay, notice that the numerator just looks like Boyle's law and the denominator looks like Charles' law and Guy-Lusset. So they just combined them together, not including Avogadro. So also we're adding the standard temperature and standard pressure. And again, they use these if they want to compare data. So it says for number 1, at a pressure of 780, and this is the temperature, this is pressure, and this is the volume. So as you can see, there are 3 variables changing, P, T, and V. Therefore, you better use this formula right here. Okay, so I'm going to write that down. At a pressure of, so P1 is equal to 780.0 millimeters of mercury. Temperature 1 is equal to 25.0 degrees C. I'm going to add 273.15 there to make it into Kelvin. So it is 298.2. This has 1 decimal place, so when I add to this, I'm rounding it to 2 Kelvin. And then volume 1 is equal to 105 milliliters. So let's say this is in San Diego. What if I want to compare it to something in Alaska? Then I have to convert these to standard conditions. This is what would be the volume if I were in standard conditions. And somebody else in Alaska would have to convert it to standard conditions as well, and we can compare that number. So it says, what will be the volume? So the V2 it's missing is equal to question mark. Under standard conditions are up here. Standard temperature is 0 degrees Celsius or 273 Kelvin. So T2 would be 273 Kelvin. And P2 should be given as well. I should only have 1 missing. So P2 is, okay, I have the center pressure to be 1 atm, and I'm going to use the same unit as millimeters of mercury, so I can cancel that. So P2 would be 760 millimeters of mercury. Okay, so these are my givens. The formula I would be using then would be P1V1. Please make sure you write the formula so I know which one you're using. Is equal to P2V2. The next thing I'm going to do is P2T2. Is plug in with the units. I'm going to plug in all these numbers. So 780.0 mmHg would be the pressure, P1. V1 would be 105 milliliters. And T1 would be 298.2 Kelvin. Is equal to, P2 is 760 millimeters of mercury, 0.0. And the new volume is unknown, so that would be my X. And then V2, T2 is 273. So as you can see, I have my conditions here in my lab. What would the volume be if I were at STP? Okay, so the way to do this problem is noticing that the units cancel, like this millimeters of mercury will cancel with this. They have to match. Kelvin will match with Kelvin. Again, if they're both given in degrees Celsius, you have to convert both of them to Kelvin. And then your answer should be in milliliters. Okay? Now, to do this algebraically, all I'm going to do is cross multiply. So this is what I'll do in the calculator. I'm going to multiply 298.2. I'm not going to write the units here, just showing you what I'm doing in the calculator. 760.0 and multiply that with x equal to, and then cross multiply this. 780.0, 105, and 273. Okay? So then to plug this in the calculator, I'm going to divide both sides by these two things, 298.2 and 760.0. The reason I do that is so it cancels and isolating the x. So divide this by 298.0 divided by, I can't read my handwriting, 760. Okay. If I were to write the units, you'll see that this cancels. This is mmHg, and this is mmHg. And you can see that it cancels. This is Kelvin, and this is Kelvin, and you see the Kelvin cancels. And this is milliliters, and you see that doesn't cancel, so your answer will be in milliliters. Okay, so in the calculator, what I would do is I would plug in 780 times 105 times 273 divided by button 298 and divided by again 760. 98.7 milliliters. Now, does this answer make sense? Oh, first the significant figures. I have 3 here, that's the least, so I'm going to use 3. Also, does it make sense? It got a little colder, pressure is lower. It's hard to tell because you have 3 variables changing, but that's the correct answer.